Hi everyone, welcome to this series of test-driven development. I'm Ritika Inani and I'm a software engineer. In this video tutorial, you will learn about test-driven development, how and why it's useful, and how to implement it in our code. You'll also learn about different styles of unit testing. Test-driven development is a very powerful approach to build robust software. Before implementing any feature, you will write unit tests for that feature, which means that tests are driving your implementation. So, before we begin with test-driven development, or TDD, as we will call it from here on, we will briefly talk about what is test automation and the importance of test automation. The most important reason is continuous delivery. The ability to make configuration changes, feature changes, bug fixes safely with just the click of a button. In order to make low-risk releases, it is important that we have test automation in place. Traditionally, testing is done on the behavior of an application without knowing the internals of the system under test. This kind of testing is known as black box testing. QA engineers manually execute all the test cases on the application in production to qualify a release. This is tedious work, and like all the tedious work, it is prone to errors. What is repetitive is boring, and boring leads to mistakes. So, that's the motivation behind automating things. Next, we have the test pyramid. The test pyramid is a concept that describes to better balance your tests. At the base of the pyramid, you have unit tests. They are reliable, easy to maintain, and gives fast feedback. Hence, it is desirable to have as many of these as possible. Going up the pyramid, the stability, reliability, and speed of the test decreases. They get harder to maintain and develop, and sometimes require complex frameworks. They are also more prone to false positives. At the top of the pyramid are high level end to end GUI tests. They run very slowly, so to have more of these tests are not feasible. Optimally, one should have large number of unit tests, which is about 70% of the total test, few end-to-end system tests, which is about 10% of the total test, and the rest in the intermediate integration tests. We are going to dig deep into unit testing and test-driven development in particular. Before we go for TDD, let's have a look at what is unit testing and few characteristics of unit tests. Unit testing is a software testing method by which individual units of source code is tested. It usually has one or a few inputs and usually a single output. Unit tests are generally small and fast. They run independent of each other, meaning that a test will be dependent only on its setup and teardown and not any other tests. Unit tests must be easy to write and maintain. They must be readable and serve as a documentation for any developer trying to read the code. All of these ensure that unit tests are reliable and never produce false positives. Unit tests can be of different granularity. Test-driven development forces one to test only one thing at a time. A class with a responsibility, a method of that class doing one thing. Other dependent classes are passed to this class as already created objects. This is called dependency injection. The dependent classes have their own tests. We will talk more about these in the following modules. Now let's come to test-driven development. So what is TDD? First and foremost, it's a discipline. Let's take an example to understand this. You might have seen in movies surgeons scrubbing their hands before a surgery. And it's not just that they scrub their hand with soap. They do it almost like a ritual. They have to lather it for a certain amount of time, scrub it for a certain number of times, etc. They are guidelines that have proved its worth through practice. Test-driven development is such a guideline. Its value is in how it is practiced. It involves writing specific tests. And the more specific test covering that unit, the more generic the code becomes. The question arises, why TDD? Imagine if you are writing code and at any point of time everything works. You make any change, you have a way to find out if it is the right change. You are more confident making changes. You spend less time debugging and all that spare time will be spent in cleaning the code. You now have the power to refactor your code as many times as time permits. Seems like a pipe dream. It is achievable through test-driven development. It is critical that developers are empowered to refactor their code without worry. No one ever writes excellent code the first time. It is an iterative process where the better code structure is evolved, and as more code is added, more refactorings are done to improve the code. When you are writing these tests, you are also telling the readers of the test on how to use the function and classes you have created. You are now creating effective documentation that will replace code kitty meetings and table reviews for learning the code. Not all code is testable. When you want to make your code testable, you automatically need to create separate independent modules that depend on each other with well-defined interfaces, and automatically it becomes clean. Now we'll come to the most important part, 3 laws of TDD, which we are going to follow. The first law says you shall not write any production code unless it is to make a failing unit test pass. That means you have a failing test case and you are writing production code only to make that test pass. If I comment that code, your test should fail. Second law says you are not allowed to write any more of a unit test than is sufficient to fail. Compilation failures are failures. When you are writing your first test, how will you know when to stop writing? The moment it begins to fail. Then you'll stop writing the test. You'll go and add the code to fix it. It passes. Again, you'll write the test, it fails, and you fix it and it passes. And the cycle repeats. The third law says you are not allowed to write any more production code than is sufficient to pass one failing unit test. This means the moment your test passes, you stop writing. I hope you have understood the 3 laws. Now we'll take an example to understand these in a better way. We'll write a simple example of how we are going to do TDD with a function to find the prime factors of a number. So let's go ahead and do that. As I'm going to demonstrate TDD in TypeScript, I have already installed Node and NPM on my system. I have created a new TypeScript project in my WebStorm, and I have installed all the prerequisites for writing the tests. We'll be using Chai and Mocha for writing our unit test. Mocha is a JavaScript testing framework, and Chai is the session library for Node.js. I have also installed TS Node, which will allow us to run the TypeScript files directly without having them to compile again and again. So I'll create a sample test file to check if everything is working fine on our local. Now, describe block is a simple way to group our tests in Mocha. It takes 2 arguments. First is the name of the test group. Let's name it as test suite. And the second is a callback function. Inside describe block, we write our actual test scenarios in the if blocks. So it will return true on success. It also takes second argument as a callback function. So expect. Let's go ahead and run our test. As you can see, I have already configured the test command in the package.json file. Let me change the path. Now we can directly run our test through npm run test. It passes. Now if I change it to false, our test should fail. It fails. So everything is working fine. Now let's go ahead and begin with our prime factors example. So, as the first law of TDD states that we should not write any more production code unless it is to make a failing unit test pass. That being said, let me go ahead and create my test file. I'll import the dependencies and I'll begin with my test suite, which is prime factors. I'll write my first test case. Okay. So I'll be calling a function. Since we don't have any function right now, let me call let's say factors of, and we can see that it fails already. So now my job is to make this failing unit test pass. We can see that it's a compilation failure. So I'll go ahead and create this function. I'll create a separate file, primefactors.ts, and I'll create a function inside this. Okay, and I'll import this file here. Okay, now still I'm getting a compilation failure. So it will receive one argument. Okay, now if you see, there are no compilation failures. So I can go ahead and run my test. Before that, let me change this to, okay. So still my unit test fails because I haven't written anything from here. So let me return an empty array to make my test case pass. And it passes. Now let me go ahead and write my second unit test. Before that, let me change the description to a more specific one. Should cert. Okay, I'll copy this same test case. Okay, and now let me run it. It fails. So I'll go ahead and change the code to make my unit test case pass. So if n is greater than 1, return array of n. Okay. Let me run the test case again. It passes. Now I'll write my next test case. And run the test cases again. It passes. So let me go ahead and write for 4. And before that, we can see that there's many repetition of these test cases. So what I'll do is I'll quickly factor my code. So I'll create a function which will take 2 arguments. And I'll copy this block. It should asserted factors of n is equal to result. Okay. Yeah. And I'll replace. Yeah. So, and I'll replace these with set factors 1, empty array. Okay, let me run the test cases again just to make sure everything is working. Yeah. So now I'll go ahead and check for 4. Our test case will fail, definitely. So now we'll make the code changes to make our test case pass. So what I can do is I'll change the condition. Okay, I'll check if n modulus 2 is equal 0, then okay, let me create one factors array and initialize it to empty, right? And then here I'll push 2 in that. Okay, and I'll remove this condition and I'll return factors from it. Okay, and one more condition, if n is greater than 1, then factors dot push n, right? And don't forget to reduce the number by 2. Reduce the number divided by 2, right? Okay, let me go ahead and run the test case again, and it passes. So I'll repeat the test case for 5 and it should return 5. Let me run that. Okay, it passes. Let's go ahead and do it for 6. Yeah, let me run it. It passes. Let's do it for 7. That will also pass, most probably. Yeah, it passes. Now let's do it for 8. And it fails, right? So what should we do? We have to modify the logic. Let me change this if condition to while loop, right? And run it again. Let's try. It passes. Great. Now we'll run the test case for 9. It should fail. Yeah, it fails. So now we can see like 9 is not divisible by 2, right? So we can do one thing. We can repeat the same logic for 3, but then there will be numbers which are divisible by 5, 7, right? So we have to repeat the same logic for those numbers as well. Or what we can do is we can make the code generic. So let's do that. What I'll do is I'll create one variable quotient, right? Then place the n with quotient. Okay, and then I'll declare a variable divisor and I'll initialize it with 2. Okay, so here 2. Okay, yeah, now we'll run. Yeah, let's change this if condition to while loop and we'll increase the divisor with 1 number. Okay, let's try running the test cases again, and it fails again. Empty array. Okay, what's the issue? Okay, we don't need this, I guess. Recommend that and run the test cases again. So it's not passing if my question is given one. Okay, sorry, I didn't initialize that question. Right. Yeah, it passes. Great. Now we can see that we never talked about the logic of calculating prime factors, right? Our tests were very specific, you can see, and we derived the whole algorithm based on our test, right? We are not writing a good logic, but we can slowly refactor the code to make it generic and optimized. We saw it in our previous initial slides also. Like, we don't write good code in the first go, but we refactor the code and then eventually we come up with good code. Okay, so now let's pass any string. Let's say 2 into 3 into 30. Okay, and we'll expect the result to be 2, 2, 3, 5, 7, 11, 30. Yeah, let's go ahead and run it, and it passes. Great. So that's how we do TDD in our code, right? We write the test cases, then we write the code, and it goes side by side, like 5 seconds to test and 5 seconds for coding. That's how it goes. So that was all about test-driven development. Thank you guys for watching this video. I would recommend you to watch our second video also, which is on styles of unit testing. Please go through that as well. Thank you so much. Thank you.